Now let's go over the derivative, the entire point of this video. So if we write f of x plus h minus f of x over h, I'm actually going to shrink this down just so we have more room. And we take the limit as h approaches 0. I might want to shrink this down to an appropriate size. There we go. This is going to be our derivative. So this equation tells us three things. And I've covered two of those, but generally we know the third one as well. The first one is the derivative. The second one is the instantaneous rate of change. So for those of you in physics, you may know velocity is the derivative of your position, and acceleration is your derivative of velocity. And I'll even cover that in a separate video for those of you who would like that. So the third thing is the slope of the tangent line. So tangent line is almost like the secant line. So let me just go back on this equation for those of you who need it. Tangent line is almost like the secant line. So the secant line touched the curve at 2 points, like we were trying to find the slope between 2 points. That's an average slope. The tangent line gives us the instantaneous slope, or the instantaneous rate of change at a single point, which is kind of what, well, not kind of, which is exactly what this means. We're taking the limit as h approaches 0, which means we want to make this h go bye-bye. So in a way, if this was, for example, f of 3 plus 4 minus f of 3, we're trying to make this 4 go away. We're trying to shrink down the distance between, we're just trying to get the slope at exactly 1 point, and I'll go through this in a problem. It's simpler to show that way rather than just explaining it like this. So yeah, let's get to a problem. So let's say we are asked to find the instantaneous rate of change at y equals 5x squared plus 3x plus 2 at the x coordinate x equals 2. So let's go ahead and write our equation down. So limit as h approaches 0 of f of x plus h minus f of x over h. So if you guys remember when I said every time you see f of something, okay, you're going to plug something in to the equation everywhere you see x, or whatever the function is. If it's f of t, wherever you see t, you plug in that something that is in the parentheses of your function. So for us, over here, we have f of x plus h. And this is our function right here. So wherever we see x, we're going to plug in x plus h. So this is going to be a little lengthy. This is why people do not like difference quotient. So let's go ahead and do that. F of, I'm sorry, let me restart that. Okay. Let's go to the top and see. Okay, so 5 times x plus h squared, come up here, plus 3 times x plus h plus 2. I'm going to shrink this again, just so we have our space. So this is right here. Oh, I'm sorry, wait. What's going on? Okay. This right here is this part right here, f of x plus h, okay? And again, we found this out by just notice the similarity, okay? Let me try and copy and paste this for you guys. Copy. Paste. Shrink. And put this up here. Okay. So notice the similarity, okay? We have 5 times x plus h squared. So this and this are the same. You have 3x plus h. So again, we're just plugging in the what we're told to plug in, x plus h, every time we see x. So hopefully that's clarifying this for you guys, okay? I'm just gonna put this minus sign in a different color so we follow along. Minus, what is f of x? F of x is just that, okay? So we're just gonna plug in 5x squared plus 3x plus 2. Again, I'm just gonna shrink this down. So we have, So we have our reference point. I am all over the place right now. I'm sorry. All right. And don't forget, this is all over h. So yes, this looks ugly, of course. That math can be ugly sometimes. That's why we're going to simplify. So let's go ahead and expand out the inside of the parentheses. So we have 5 times x squared plus 2xh plus h squared. Again, I'm just going to shrink this down. So right now, this and this are the same. Plus, I'm just going to expand this one out, plus 3x plus 3h. That's simply the distributive property. Now, right now, I just want to deal with this. We're not going to rewrite the rest. We're just going to deal with this just to simplify this out. So we're going to have 5x squared plus 10xh plus 5h squared plus 3x plus 3h plus 2. That looks good. Over here, if we were to factor this negative in, we'd have minus, 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 and that would be a plus. So we're going to go and factor that in. And the beautiful thing about the difference quotient is that almost everything cancels, okay? So notice you have 5x squared here, and then you have minus 5x squared. So this and this cancel. Great. You have a 3x minus a 3x. Great. 2 minus 2 is 0. 3x minus 3x is 0. Oh, and how convenient. You have a 2. Oh, I'm sorry. You have a 2 minus another 2. Those cancel. That gives us 0. So what are we left with? 10xh plus 5h squared plus 3h over h. Now, we need to remember something, okay? You cannot forget this. This was limit as h approaches 0, okay? Forgetting this defeats the whole purpose of this, okay? Right now, if we were to plug in right now if you were to plug in h equals 0, I hope you understand we would get undefined because of this little guy right here. Well, lucky for us, because of what we did, the only variables we have, minus this little x right here, we'll get to that though, is h. And guess what? Each one has an h, which means we can now actually divide everything by h. So we can just factor this out. So h 10x plus 5h plus 3 over h. H and h go away. So now you have 10x plus 5h plus 3. The limit up here is telling us wherever we see h, we plug in 0. AKA make it go bye-bye. So what are we left with? 10x plus 3. Wonderful. That is so much simpler than all that crap we had to deal with. So if we come all the way up here, we were given at x equals 2. Well, guess what? We have a little spot for x right here. So at x equals 2 simply means plug in 2 for wherever we see x. Guess what? This right here is the slope, the instantaneous rate of change, the slope of the tangent line at the point x equals 2. So if we were to graph this equation right here, and we looked on the graph at the x coordinates, so when, I'm sorry, that's a bad way to show it. Let me show this in a much neater manner. So when you plugged in 2, you'd probably get a number way up here. And I mean, we obviously know we would, because what would that number be if we plugged 2 in? Well, you would just plug in 2 into this equation, right? So you would have, let me make some room. I can just erase this because you guys can just go back and copy this down. So we would have 5 times 2 squared plus 3 times 2 plus 2 gives us 20 plus 6 plus 2 gives us 28. So when we plug in 2, our y coordinate is 28. Okay? And, well, so let's say this is 2 comma 28 right here. Okay? And because it's so high up there, and because we also see like this 5 here, we know the slope is going to be fairly steep, right? So it makes sense, right? It's logical to understand that the slope is 23. So if you somehow get a slope of 57 and you start doubting yourself, just look at the original equation and plot the point before it if there's a huge jump, okay? So like if we plugged in 1, I'm just gonna make this short for you guys and do this. 5 plus 3, 8 plus 2, 10. We're going from 1 comma 10 to 2 comma 28. We went up 18 units in a 1x interval. 1 unit of x interval. That is an incredible jump. So the slope being 28 makes sense. So you can always use logic as well to make sure that your answer is correct. Now I'm going to show you guys a simpler method of solving this. So our equation was 5x squared plus 3x plus 2. And we want to get this in pretty much one step, okay? Now I'm just going to show you guys how, this in this video, and then next video I'm going to go into the thorough explanation of how to do this. So y prime, which just means the derivative dy dx, equals 2 times 5 times x plus 3, which gives us 10x plus 3. What did he just do? Was that magic? No, it wasn't magic, silly. That was math. Math at its finest. So yeah, I'm going to explain this rule in a different video. So don't worry, don't panic. That's the shortcut. What I just showed you is probably required by your teacher. This is the definition of a derivative. Only when there's a limit in front, okay? If there's no limit, then that's just slope. When you have the limit in front, as h approaches 0, that's going to be the derivative. If there's anything else that I have not clarified for you guys in this video, please let me know, or in the series of videos rather. And I will try and clarify that for you guys next time. One last thing I should probably note. If you're given this equation, okay, this equation right here, and you are asked at x equals 2, not only what is the slope of the tangent line, but what is the equation of the tangent line, it's very simple, okay? So we already found the slope, right? It was 23. So m equals 23. And you know your x-coordinate, it's x equals 2. And you know your y-coordinate, because I showed you guys that, all the way up here. Where is it? Oh, well. You get 28 when you plug in 2 into this equation. So, hold on. X equals 2, y equals 28. So at this point, you have a point, which your point is 2, 28, and you have a slope. So what do you do when you have a slope and a point? You, my dear friends, you have to do slope-intercept form. I'm sorry, point-slope form. So y minus y1, so minus 28, equals your slope, 23, times x minus x1, which is just 2. And you could leave your answer like this, or you have to turn it into slope-intercept form. I'm sure you guys can do that. Both answers are correct. You could even put it in standard form, but no one likes that. But your teacher might, so I don't judge. So yeah, that's all for this series of videos. Again, if there's something I didn't cover, please leave a comment and I'll try and get to that. So thank you for watching.